Hi, my name is Destiny Tudara and this is Tudaratutors. Today I'll be going over the unit circle and different aspects of it to help you better understand it. Uni is the Latin prefix for 1 and the unit circle has a radius of 1, so it only makes sense. When we're dealing with the unit circle, we deal with the circumference. The circumference is just the linear distance around the circle. So think of it this way. If you were to take a string and you were to measure the distance, the length of that string, it'd be very simple. However, if you were to make a circle out of it, it becomes a lot more difficult. This is why we have the circumference formula. So the circumference formula is equal to 2 times pi times the radius. Since the unit circle has a radius of 1, the circumference of the unit circle would be 2 times pi times 1, or just 2 pi. What are radians? Well, by definition, radians are a unit of angle equal to an angle at the center of a circle whose arc in length is equal to the radius. No matter what the value of the radius, 1 radian will always equal 180 degrees over pi. This is because the value of the radius is proportionate to the circumference. So as the radius gets bigger, the circumference also gets bigger. That's why it's always 180 degrees over pi. Let's do some math. So we know that the circumference is 2 pi and there are 360 degrees in a circle. So let's set 2 pi equal to 360. Divide both sides by 2. We have pi equal to 180. So for every distance pi around the circle, the angle would be 180 degrees. Converting degrees to radians. So if we have the angle, we can find the radian equivalent just by what we found out previously. Well, we found out that pi is equal to 180 degrees, so we're going to multiply our angle by pi over 180 to find the radian equivalent. So let's take 30 degrees for example. We would do pi over 180 times 30, which would equal 30 pi over 180. Simplified would be pi over 6 radians. Pi over 6 radians is the equivalent to 30 degrees. Multiplying any angle by pi over 180 will give us the radian equivalent of that angle. I challenge you to pause this video and reference the unit circle, pick any angle on there and multiply by pi over 180 and see if you get the correct answer. So now that we know how to convert degrees to radians, how do we find out the points on the unit circle? Well, there's a few things we need to understand before we get into that. We need to understand the right triangle. A right triangle is a triangle with a right angle and an angle that we reference called theta. Using theta, we are able to use SOHCAHTOA, which is sine theta equals opposite over hypotenuse, cosine theta equals adjacent over hypotenuse, and tangent theta equals opposite over adjacent. Cosine theta is equal to the distance you move in the x direction, and sine theta is equal to the distance you move in the y direction. This is why it's important to know how to use SOHCAHTOA, because we use it in trying to find the point on the circle at that specific angle. So how do we use SOHCAHTOA? Well, if you notice that in the first quadrant, the angles we were taught to memorize are 30 degrees, 45 degrees, and 60 degrees. This is because we use two types of right triangles. A right triangle with angles measuring 90 degrees, 60 degrees, and 30 degrees, and a right triangle with angles measuring 90 degrees, 45 degrees, and 45 degrees. Both triangles have properties associated with them that help us identify the length of all the sides. Remember, the sum of all angles in a triangle is always 180 degrees. Properties of right triangles. The 30, 60, 90 triangle, all you need to know is the length of one side. So you're going to set a variable x for the shortest side of the triangle, and then the hypotenuse, which is the side opposite of the right angle, is going to be 2 times that, so it would be 2x. And then the medium length side is going to be root 3 times x. So you're going to have x root 3, and 2x. In the case of the unit circle, we know that the radius is equal to 1. Well, the hypotenuse is always equal to the radius, so we can set the hypotenuse, which is 2x, equal to 1. That would give us a value of 1/2 for x, and we're going to plug in 1/2 for x into our triangle on the left, and we're going to get the values now on the right. So now our values for our triangle will be 1, 1/2, and root 3 over 2. For the 45, 45, 90 degree triangle, both the opposite and adjacent sides are equal. So using this information, we can use the Pythagorean theorem, which states that a squared plus b squared equals c squared, and we can figure out all the lengths of the sides. So we have a squared plus b squared equals c squared, and we're going to use x as our variable in lieu of a and b because a and b are both the same, so we can do that. So x squared plus x squared equals 1 squared. Simplified would be 2x squared equals 1, and divide both sides by 2. X squared equals 1/2. Take the square root of both sides. X equals the square root of 1 over the square root of 2, which would be 1 over root 2. And we don't like radicals in the denominator, so we're going to multiply by root 2 over root 2, which is the same thing as 1. It's just a way to kind of manipulate the fraction. And our final answer is going to be root 2 over 2. Since we have the lengths of all sides of our triangles, we can now use SOHCAHTOA to find the point on the circle. Remember, the point on the circle is x comma y, or cosine theta comma sine theta. Well, sine theta equals opposite over hypotenuse, cosine theta equals adjacent over hypotenuse, and tangent theta equals opposite over adjacent. What this means is we have our reference angle theta, and the side opposite of that is opposite. The side adjacent to that, that's not the hypotenuse, is adjacent, and the hypotenuse is always the side opposite of the right angle. Let's start by finding sine theta and cosine theta, where theta is equal to 30 degrees. Well, we know that sine theta equals opposite over hypotenuse, so we'll have 1/2 over 1, which would just give us 1/2, and cosine theta is equal to adjacent over hypotenuse, which is root 3 over 2 divided by 1, which is just root 3 over 2. Now let's find cosine theta and sine theta, where theta is equal to 45 degrees. Well, sine theta is equal to opposite over hypotenuse, so root 2 over 2 divided by 1, which is root 2 over 2. And cosine theta is equal to adjacent over hypotenuse, so root 2 over 2 divided by 1, which is root 2 over 2. Now let's find sine theta and cosine theta, where theta is equal to 60 degrees. Well, sine theta is opposite over hypotenuse, so root 3 over 2 over 1, which is just root 3 over 2, and cosine theta is equal to adjacent over hypotenuse, so 1/2 over 1, which is just 1/2. So what about the other quadrants? Those angles aren't 30 degrees, 45 degrees, and 60 degrees. Well, it's a little more complicated than that. So it depends on where you draw the base of your triangle. So for example, quadrant 2, if we draw the base of our triangle at 180 degrees, and we draw our triangle to 150 degrees, we're going to subtract 150 from 180, which would give us 30 degrees for theta. So if you notice, all values for x and y on the circle are similar in all 4 quadrants. The only difference is the polarity. Polarity in the unit circle. So I provided 2 pictures. One is just the polarity of the unit circle. The bottom is the unit circle to include the points, the radians, the degrees, and all of that, just so you can kind of see. In quadrant 1, which is the upper right-hand corner of the unit circle, we have both positive values for sine and cosine theta, or x and y. And in quadrant 2, we have a negative value for x, or cosine theta, and a positive value for sine theta, or y. And in quadrant 3, which is the quadrant right below that, we have a negative for both cosine theta and sine theta, or x and y. And in quadrant 4, we have a positive value for x, or cosine theta, and a negative value for sine theta, or y. This concludes today's video. Comment below or email me at tudaratutors@gmail.com, and I'll do my best to answer any questions you may have. Also, give a thumbs up and subscribe, and I'll see you next time.